Okay, we have a charge Q1 at point X1, Y1, and we want to find the electric field E1 at a point XY. We can use the definition of the electric field as KQ over R12 squared times R12 over the R12 vector over R12 magnitude, where R12 is the vector from the point at which the charge is to the point at which we're calculating the field. And it's simply a matter of doing this in symbols. It's simply a matter of writing it out. So E1 is K times Q. Q in this case is the charge Q1. Okay, now we've got to look at R12. What's R12? Well, the vector R12 just goes in the x direction from x1 to position x. So you're going to have x minus x1 times I. And from y position y1 to position y, so the j component is y minus y1. So here's your R12 vector, and we can fill in everything else, because everything else is just either the R12 vector or the magnitude of the R12 vector. So R12 magnitude is the square root of x minus x1 squared plus y minus y1 quantity squared. That's going to go here underneath the R12 vector. This is your unit vector in the direction of R12. R12 squared is just the square of this square root, so that's just x minus x1 quantity squared plus y minus y1 quantity squared. Now if we have a charge Q2 at point x2, y2, then at the point x1, y1, we get a very analogous result. We're going to get an electric field E2, and we can simply write that down. The expression is identical to the expression we have here, except Q1 is going to be Q2, X1 and Y1 are going to be X2 and Y2, since that's the position of the Q2 charge. So we could, if we wished, add the E1 and the E2 and get the resultant field at this point. Now the fact that you can do that, the fact that if you have two or more charges, you can calculate the resulting electric field at a given point, xy. We could call that point anything we want to. We could calculate the electric field at any given point by simply calculating the electric field due to one charge, the electric field due to the other. And if there are more charges, we calculate the electric field due to each of them. The resultant electric field is E equals E1 plus E2 in this case. It would be the sum of all the electric fields from all the other electric charges if we had more than two. Now let me emphasize, this is not along the lines of a formula you should remember. You should remember this, and you should understand the sense of it. This is a result of your basic formula for the electric field due to a point charge.